Hi, today we are going to learn about linear inequalities from section 2.8 in your text. An inequality looks like an equation, except we've replaced the equal sign with an inequality symbol, less than, greater than, less than or equal to, or greater than or equal to. Remember that when we represent equations or inequalities like this with capital letters, those capital letters are replaced by any real number. X is the unknown in these inequalities. Here's some examples. X plus 5 is less than 2, z minus 3/4 is greater than or equal to negative 5, or 2t plus 1/2 is less than or equal to 10. The addition property of equality said that when we had an equation, A is equal to B, and we added the same thing or subtracted the same thing to both sides of the equation, we still had a balanced or equivalent equation. The same thing is true with inequalities. If we have A is less than B and we add the same thing to both sides of the equation, we still have a balanced or equivalent inequality. Remember that addition and subtraction are paired properties, so you can either add or subtract the same thing to both sides of the inequality and you still have a balanced or equivalent inequality. Let's use that to solve an inequality. X minus 3 is greater than or equal to negative 1. I want to get the x by itself. I add 3 to both sides of the inequality. Negative 3 plus 3 is equal to 0. That leaves me an x on the right is greater than or equal to negative 1 plus 3 is 2 on the right. X is greater than or equal to 2. We've got the x by itself, so that's our solution written in inequality form. I transferred that to the right side of the screen. We can also write that same solution in set builder notation by using curly brackets. This says that x can be any real number such that x is greater than or equal to 2. Another way to write the solution is to put it on a number line. We start with the number 2. We're going to use a square bracket here and we fill in to the right. You shade in on the number line, and I'll want to see that your number lines are shaded in heavily in the direction that would form solutions to the inequality. Notice that the inequality points in the direction that I'm shading when the variable is on the left. We can also write the solution in interval format. Note that my left side of my interval is a square bracket just like it was on the number line. We start with the number 2 and we go all the way up to infinity in our interval. Infinity always uses an open bracket. We can also check our solution. Let's plug in 2 for x. We would have 2 minus 3, which is negative 1. Negative 1 is greater than or equal to negative 1. Well, negative 1 is equal to negative 1, so this makes a true statement. What if we pick a number from the region that's shaded on our number line? Let's pick 5. 5 minus 3 is 2. 2 is greater than or equal to negative 1. It's certainly greater than, so again, a true statement. Notice that all of the numbers that are in our shaded region on our number line will form a true statement if we pick a value and put it back into the equation. What if we pick a value from the side of the number line that's not shaded? Let's pick 0. 0 minus 3, that's negative 3, is greater than or equal to negative 1? That's false. Negative 3 is less than negative 1, so that makes a false statement, and notice it's not shaded on the number line. We use the square brackets to indicate that the endpoint is included, that the inequality has an equal symbol in it. If we have x is greater than or equal to negative 3, we would put this on the number line by using a square bracket, and notice we would shade to the right. If we have x is less than or equal to 0, we're going to start at 0. We use a square bracket, but it points the other direction, and here we shade to the left. If the inequality does not have an equal symbol, we don't include the endpoint in the solution. So if x is greater than negative 3, we start at negative 3 on the number line, but we use a parentheses-like symbol to indicate that we don't include the value of negative 3 in our solution, but we shade to the right. If we have x is less than 0, we start at 0, but again we use the open symbol to denote that the value of 0 is not included in our solution. What does that really mean? Well, if I pick the value of 0, 0 is less than 0? No, that's not true. 0 is equal to 0. So using the value of 0 creates a false statement. That means we can't use the value of 0 in our solution set, but from 0 to the left, not including 0, is included in our solution set. So if we pick -5, -5 is less than 0. That makes a true statement. In previous text, you might have used open circles and filled in circles to indicate open and closed intervals. Our text uses the square bracket and the symbols that look like parentheses. Also remember, when the variable is on the left, our inequality points in the direction that we shade on our graph. Greater than, we shade to the right. If the inequality is less than or equal to, notice we shade to the left. The inequality points in the direction we shade when the variable is on the left of the inequality. Let's try another one. 5 plus 5x is less than or equal to 4x plus 3. We want to get the variable x by itself using the addition property of inequality. I'm going to subtract 4x from both sides because remember, I like to keep my variable terms or my variables positive. I can start a different way. I could subtract 5 from both sides, but because I like to keep my variable positive, I'm going to start off by subtracting 4x. 4x minus 4x is 0, so if we do the math, we have 5 plus 1x is less than or equal to 3. I want to get the x by itself, so the next thing I'm going to do is subtract 5 from both sides. 5 minus 5 is 0. That leaves me an x on the left is less than or equal to 3 minus 5 is -2 on the right. We've got the x by itself, so that's our solution written in inequality form. I'm going to write that under the inequality solution on the right-hand side. In set builder notation, that would look like x, any real value of x, such that x is less than or equal to -2. When we move that to a number line representation, we're going to start at -2. This one's going to have a square bracket because it's got an equal sign in the inequality, and we shade to the left, the direction the inequality points when my variable is on the left. Notice that the inequality pointed to the left, we shade to the left. In interval notation, we start with the open symbol because we're starting at -infinity. As we move toward the right, we hit our -2, and we've got that square bracket to close our interval notation. Notice that that square bracket on the number line lines up with the square bracket on the interval, and that infinity always has an open symbol, whether it's -infinity or +infinity. Now we can check our solution. Let's choose -2 and plug it in for x. We'll have 5 plus a -10, that's -5. On the other side we have 4 times -2, that's -8. -8 plus 3, -5. Well, -5 is equal to -5, so that makes a true statement. What if we pick a value that's not shaded on our number line? Let's pick 0. 5 times 0 is 0, and 4 times 0 is 0, so that leaves us with 5 is less than or equal to 3. That's not true. 5 is greater than 3, so that's a false statement, and we had picked a number that wasn't from the shaded region on the number line. We could also check -5 or another value that's shaded on the number line, and we'll end up with a true statement. You might want to try that yourself. Just like we have the addition property of inequality, we have the multiplication property of inequality that works for both multiplication and division. They are paired properties. With the multiplication property of equality, if we had the equation A is equal to B and we multiplied both sides of the equation by the same number, we would have a balanced or equivalent equation. The same thing works with the multiplication of property of inequality with a caveat. If A is less than B and we multiply both sides of the equation by a positive number, we end up with a balanced or equivalent inequality. If we multiply by a negative number, though, we've got to flip the inequality. Notice that the inequality is pointing in a different direction. Let's look at why. If we have the inequality 3 is less than 7, and we multiply both sides of the equation by a positive 2, we'll end up with 6 is less than 14. That's a true statement. But if we multiply both sides of the inequality by a negative number, we'll end up with negative 6 is less than negative 14. That's not true. Negative 6 is greater than negative 14. It's to the right of negative 14 on the number line. So to make a true statement, we have to flip the inequality. Remember, if you multiply or divide by a negative number, reverse the inequality. You need to remember, if you multiply or divide by a negative number, reverse the inequality. Let's apply the multiplication property of inequality to solve some inequalities. I want to get x by itself, so I'm going to divide both sides by 3. 3 over 3 is 1, so on the left-hand side I've got x is greater than negative 12 divided by 3 is negative 4. That's our solution written in inequality form, and notice I didn't flip the inequality because I divided by a positive number, not a negative number. X is greater than negative 4 is our solution written in inequality form. To write the solution in set builder notation, we write it any real number of x such that x is greater than negative 4. To put that on the number line, we start at negative 4. We're going to use an open symbol because the inequality does not have an equal. We're going to shade to the right, and notice that our inequality points to the right. When the variable is on the left, we shade to the right. In interval notation, we're going to start with an open symbol, just like we did on the number line. First value is negative 4, comma, infinity, because we go clear to the right, and infinity is always followed by an open symbol. Notice that the symbol on our number line and in our interval match. We used an open symbol on the number line, an open symbol in the interval, and infinity always has an open symbol. We can check our solution also. If we use the value of negative 4, notice that 3 times negative 4 is equal to negative 12. So if we had an equation, that would make a true statement. But negative 12 is not greater than negative 12. It's a false statement. It's a good way to check your work to see if you did your math right, because if you replaced the inequality with an equal sign, you would have a true statement. Because it's an inequality, though, this is false. That's why we use the open symbol in our notation. Let's pick the value of 0. That's in our shaded region. 3 times 0 is 0. 0 is greater than negative 12. That's true. Let's pick a value that's in our region that's not shaded, negative 5. 3 times negative 5 is negative 15. Negative 15, that's less than negative 12, not greater than negative 12. That creates a false statement, and it wasn't shaded on the number line. Let's try another one. Negative 5y is greater than or equal to 15. To get the y by itself, I'm going to divide both sides by negative 5. Negative 5 over negative 5 is 1. That leaves me a y on the left-hand side. 15 divided by negative 5 is negative 3. And notice I flipped the inequality because I divided by a negative number. If I multiply or divide by a negative number, I've got to flip the inequality. So the solution written in inequality form is y is less than or equal to negative 3. In set builder notation, we would write it as any real value, any real number y such that y is less than or equal to negative 3. To put it on the number line, we'd start at negative 3 with a square bracket, and we'd go to the left. We'd fill in to the left. In interval notation, we start with that open symbol because we're at negative infinity on the left. As we move to the right, we hit negative 3, followed by a closed bracket. Notice that our number line closed bracket and our interval notation closed bracket are lined up, and infinity, whether it's negative or positive, always has the open symbol. We can check our solution. Let's pick negative 3. Negative 5 times negative 3 is 15. 15 is greater than or equal to 15. That's a true statement. If we pick the value of 0, which is not in the shaded portion of our number line, negative 5 times 0 is 0. 0 is greater than or equal to 15? That's false. And if we pick the value of negative 5, which is in the shaded part of our number line, we'd have negative 5 times negative 5. That's 25, a positive 25. 25 is greater than 15. That's a true statement. So the steps for solving linear inequalities are: first, simplify each side separately. Then isolate the variable term. We're going to use the addition property of inequality to do that. Next is you isolate the variable. You use the multiplication property of inequality. And remember, change the direction of the inequality if you multiply or divide by a negative number. We check solutions then and use the original inequality to do that, just in case you made a math error. And finally, you write the solutions in one of 4 forms or all 4 forms: in inequality form, set builder notation, on a number line, or in interval notation. Let's try some. Here's an inequality. 3a plus 2 minus 5 is greater than or equal to negative a plus 7 plus 2a. I'm going to simplify each side of the inequality first. On the left-hand side, I can combine 2 minus 5 to get negative 3. So on the left-hand side, I've got 3a minus 3. On the right-hand side, I can combine like terms. Negative a plus 2a is a plus 1a. Notice I just wrote that as an a, and I've still got my plus 7. Now I want to get the a's on the same side, and I like to do that by keeping my variables positive. So I'm going to subtract a from both sides. A minus a is 0. 3a minus a is 2a, so I have 2a minus 3 is greater than or equal to 7 on the right. Now I want to get the variable term by itself, so I'm going to add 3 to both sides. Negative 3 plus 3 is 0. That leaves me a 2a on the left, and 7 plus 3 is a 10 on the right. Now to get the a by itself, I divide both sides by 2. 2 over 2 is 1. That leaves me an a on the left, and 10 divided by 2 is 5 on the right. Notice I divided by a positive number. I didn't change the direction of the inequality. A is greater than or equal to 5 is my solution written in inequality form. Set builder form, I can use any a such that a is greater than or equal to 5. On the number line, I start at the value of 5 and I go to the right. That's the direction my inequality points. I use a square bracket because I've got an equal in my inequality. Interval notation, I'm going to line up. Oh, notice that I'm pointing to the right because my inequality points to the right when my variable is on the left. In the interval notation, I start with a square bracket. I start with the value 5. I move toward the right where I hit infinity, and with infinity I always use that open symbol. Notice that that square bracket is lined up with the left end of my interval notation, and my infinity is on the right with an open symbol. Let's check our solution. If we use the value of 5 and plug it in, check my math. Make sure I did it right. You can pause the video here to see what the math looks like. And when I'm done, I end up with 12 is greater than or equal to 12. That's a true statement. What if I pick the value of 0 and plug in 0 for a? 3 times 0 is 0, and then I have my 2 minus 5. Negative 0 is still 0. 2 times 0 is 0. So when I do all the math, 2 minus 3 is negative 3 is greater than 7. Notice that that's false. And I took that value from the part of the number line that's not shaded. I would expect a false value. You might try a value here that's in the shaded region, say 6 or 10, and see if they create a true statement when you check the solution. Anything in this shaded region should create a true statement when you do the math. Here's another one. I would suggest pausing the video here, doing the work on your own, and then starting the video again to check your answer. Here we go. I'm going to combine like terms to simplify each side of the inequality separately. Negative 2t plus 5t is 3t. The right side is already simplified. Now I want to combine the t's, get the t's on the same side of the equation, and I like to work with my variables positive, so I'm going to subtract 3t from both sides of the equation. You might have gone a different direction. You should end up in the same place as me. 3t minus 3t is 0. 8t minus 3t is 5t. So I've got 6 is less than or equal to 5t minus 4. Now I want to get the variable term by itself, so I'm going to add 4 to both sides of the equation. Negative 4 plus 4 is 0. Left-hand side of the equation, 6 plus 4 is 10, is less than 5t. Now I want to get the t by itself, so I'm going to divide both sides of the equation by 5. 5 over 5 is 1. 10 over 5 is 2, so 2 is less than or equal to t. I ended up with my t on the right-hand side, and that doesn't work well when we transfer it to a number line. So I'm going to reverse it so the variable is on the left. That means that I have to reverse the inequality too. So when I flip it so that my variable is on the left, I also have to flip the inequality. T is greater than or equal to 2. So my inequality is t is greater than or equal to 2 in set builder notation. Any value of t such that t is greater than or equal to 2, all in curly brackets. On the number line, I start at 2. I use a square bracket because I've got an equal sign in my inequality, and I shade to the right. Notice that my inequality points to the right. I shade to the right, but my variable has to be on the left for that to work. That's why we flipped the inequality. In interval notation, I start with the square bracket. It lines up with my number line. Start with the value 2, go to infinity. Infinity always has an open symbol. Notice that my number line, my interval notation line up. I start both of them with that square bracket, and infinity always has the open symbol. Again, we can check our solution. If we pick the value of 2 and plug that in for t, when we simplify everything, we'll end up with 12 is less than or equal to 12. That's a true statement. Notice I went back to my original equation to check the solution. You can also pick values in the shaded region and the not shaded region to make sure that you've done the math right. You might want to check your solution with other numbers as well.